Will you ever buy a car without a test drive? Will you ever serve food to guests without first tasting it yourself? Well, obviously not. That's the importance of testing in our daily lives. Now imagine its importance in the software industry. Let me share a real incident. All of you have traveled by VR at some point, right? For those who are new to Finland, VR is the Finnish State Railways. They started their biggest ever IT project to reform the ticketing system in 2008, which was finally completed in 2017. The experts had designed a system that could withstand even the toughest visitor peaks. The first counter was opened in Turku on 14th of September at 5 o'clock. At 7 in the morning, statistics started to rise when people started to wake up. Between 8 and 9, the number of visitors broke all previous records, including security clearance that the system was designed for. Soon, some of the customers could no longer access the service, and even those who got there had to wait for the download of the pages, at worst tens of seconds. The situation got even worse when noon approached. Equipment for customer service became increasingly slower, and the new cheerful green ticket sales machines started to get jammed all over Finland. The underlying problem was that stress tests were planned based on previous user numbers, and oversized traffic was not considered. This clearly shows the failure in estimating testing scope and effort. 30% of projects fail due to undefined risks which are not foresighted. 27% of projects fail due to inadequate testing estimates. Statistics clearly show 1 in every 3 projects is failing due to lack of test effort estimation. How do you measure test effort? Unlike cooking, where the time and spent variety of ingredients used matters, in software, lines of code, number of asserts, data creation points are the metrics that indicate the complexity of code change, which will be used to measure our test effort, so-called serve as predictors. With every code change, new test cases are added and existing ones are modified, which results change in overall test execution time. These 3 parameters will serve as the metrics which will express test effort. What machine learning are we applying here? We are referring to past studies that used multivariate regression models and had savings from 47 to 95% in software testing costs. Significant results have been found while working with neural networks, decision trees as well. Poor software testing has made brands like Apple lose their reputation. Remember when they first launched their version of Maps? Any user who has a bad experience with a software or app would pass on a negative feedback to their peers, as expected. But do you know that it takes 40 positive feedbacks on average to rectify that one negative feedback? Companies must pay 80 to 100 times more when the defect or so-called bug is detected post-product launch into the market. The finance team of VR can surely attest to this. What's even worse is that the time spent to fix it is 50 times longer. Having been a part of software development world, we as a group feel naturally attached to devising new ways of automating and to reduce expenditures such as time. Team 6 of EDIS consider ourselves fortunate to have an opportunity to collaborate with Adwar and Jan from the Sweden University. Thank you.